here you can see lines here are called isoprofit lines. So any point you are choosing here will give you the same profit, such as, let's say I'm choosing particularly, let's say this edge or this point here, x is 70, x is, let's say, 70, right, and y is 0. So after putting that, 70 into 10 is 700 plus 0, so profit is 700. Let's say I'm choosing another random point here, let's say this one, 50 into 14, that is 700 plus 0, so profit. Again, I can choose different combinations, and they are called isoprofit lines because profit is constant here. Any point you choose, it will give you a value of 700. Okay, let's choose any point here on this 350 line. So 35 into 10, that would give me 350, and somewhere over here maybe 25 or 24, any 25 into 14, so that will give me 350. Okay, how do I get the other constraint line? So what I need to do is put this portion, 2y portion, as 0. So x will be 120 divided by 3, which is 40. So this is my 1 point. And for second, I'm going to put this 3x x portion as 0. So 2y is equal to 120 divided by 2. Y is 60. So second point here is this one. So I need 2 points for a line. I need to draw a line between which will go through these 2 points, right? Let's talk about the second assembly line constraint. X, just by simply putting to this portion as 0, so x is equal to 80, and for the second portion, y is equal to 40. So x is here 80 and y is 40 here. So region, this blue region is where my feasible solution will lie, and now this is also satisfying the all constraint. So this blue region is very important. This is constraint 1. I cannot go out of this blue region because then it is violating my constraint 2, this here. If I am somewhere over here, then it's also violating my constraint 1. So I have to understand and not violate my constraints here. Okay, so after just dragging this isoprofit line up and up until it reaches where it is touching with constraints, or second method could be very easy. The method I just discussed is graphical method. Other, just very simple. For the point, the solution exists as at the corner, so I cannot take this corner because it's violating my constraint 1 here, this line. So here, this one, it will give me 400 into 10, 40 into 10. This will give me profit of 400. Here profit is 0 0. Here y into 40, and the profit is 14. So 14 into 40, it's gonna give me 560. How about this line here? 20 into 10 and plus 30 into 14. 14 is profit for y, and it comes out to be 620. So this is the you can say, okay, maximum profit points within constraint, and it comes out to be 620. So this is our required point. I need to produce 20x per day, or 20 product X and 30 product Y, and it's satisfying all the constraints, and it in addition it is giving me maximum profit. In reality, we have more than two variables, such as in this particular problem we were only talking about machining and assembly. So computer solution called simplex method has been developed to be used with many variables. And this method is forging technique in a mathematical algorithm that permits computer solution of linear programming by considering like many variables. So for example, AT&T model of current and future telephone demand has got 42,000 variables, taking 4 to 7 computer hour for a single run. Here is another very simple example of um, a linear programming. Here this just remember that we have to take uh, this non-negativity constraint. Okay, uh, the spreadsheet, like if we can solve linear programming related examples or questions with the help of Excel spreadsheet. So first of all, I need to activate this Excel solver. So here I have explained that in step by step. Here just go to the adds in, and then click on Excel solver add in. By checking it, click OK. Once it is activated, then just follow the steps given to you in PowerPoint presentation step by step, and you can easily solve the same example which we discussed by graphical method. You can solve it in Excel spreadsheet. In addition, I will be sharing the Excel spreadsheet with you people also. Okay, so um, right, let's talk about decision under risk. So in decision making under risk, one assumes that there exist a number of possibilities, a number of possible future states of nature, Nj. So each Nj has a known, or we can assume, probability, which can be denoted by Pj of occurring, and there may not be one future state that results in the best outcome of all alternative. So for example, example of future states and their probabilities could be, right, alternative weather, and 1 is equal to rain and 2 is equal to good weather. So this will affect the profitability of alternative construction schedule. Here P1 is the probability of rain, P2 is probability of good weather, can be estimated from historical data. So we can like use historical data in order to guess that what would be the probability of rain, or what is the probability of good weather. Right, another example would be for economic futures. So boom or bust determine the relative profitability of conservative versus high risk investment strategies. Here, the assumed probabilities of different economic future might be based on judgment of a panel of economists. So it's like very simple uh, method. First one is the expected value method. Very simple. So let's say given the future state of nature and their probabilities, the solution in decision making under risk is the alternative AI that provide the highest expected value EI, which is defined as the sum of products of each outcome OIJ times the probability J that associated state of nature and J occurs, right? So let's say here I have a very simple example here. Here I have a very simple payoff information. Here it's given in the table that I have two alternative decisions and two possible state of nature. Alternative A1 is that whether I insure house, and second one A2 is that I do not insure house. So two things can happen. Let's say if there is a fire, right, in my house, so, and if there is no fire, so two scenarios can happen. And if I have insurance here, I don't have to worry about anything. Every month I will be paying an insurance of $200, and whatever are the damages caused by fire will be let's say paid by a insurance company. Second one is, let's say I do not insure the house. If there is no fire in house, that's very good. I don't have to pay $200 per month to the insurance company. However, the second scenario here is, let's say if there is a fire in my house and I don't have any insurance, so the damages would be minus $100,000 and I will be paying it from my pocket because I don't have any insurance, right? So question would be, what should I do? Should I go for alternative 1 here, A1 or A2? Our solution would be to calculate the expected value, and that would be, here you need to know that the probability of night fire in your house is 0.999 and fire in the house is 0.001. So probability of not fire in your house is very high, which is a good thing, right? Even would be pi, which is 0.99 multiplied by alternative value minus 200 plus 0.001 into minus 200. So this is the first even value for my insurance. Let's say I have insurance. Expected value comes out to be minus $200 because I am paying minus $200 every month, or let's say every year. So it doesn't matter if there is fire in my house or not, because the damages will be paid by the health insurance, or let's say any insurance company. Second would be, and I don't have insurance, so 0 multiplied by 0.999 plus P2.001 multiplied by this value minus 100,000, so it comes out to be minus $100. Because it's a minus, it's going out of my pocket, so I will definitely go for E2. Do not insure a house. You need to remember that this is for a long run. It's like the expected average value. You cannot say that, okay, I didn't do insurance for my house and next month unfortunately it was like fire in my house. So this thing is basically on average. So like I said, the expected value of your fire loss, as it will be paid by insurance company. However, if you are like most people, you will probably buy the insurance because quite reasonably your attitude toward risk is such that you are not willing to accept loss of your house. The insurance company has a different perspective here. Since they have many houses to insure and can profit from maximizing expected value in the long run, as long as they do not insure too many properties in the path of same disaster, right? So insurance company, they have different perspective, and a user, they have a very different risk attitude. However, on paper, E2 is your solution, not to insure uh, your house.